Good Monday morning to you. I had back in 2010 gone to Craig Van Battenberg's Up Your Voltage 18 school. That's how long ago that was, if you know how many Up Your Voltage sessions he's had. But I started learning about hybrid vehicles there, and I came back and I had to teach it. One of the things that I was required to teach as an instructor at college, and I had to put together a lot of stuff beyond what I learned from Craig. Of course, a lot of the stuff that Craig teaches goes deep, 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 you know. And so what we're going to do is going to hit the highlights today. Some of this stuff is going to sound like it's kind of advanced. We're going to try to make it as simple as we can. Now, this is a basic layout, you know, and there's different kinds of hybrids and all that kind of stuff. And we're not going to dig into all of that stuff, you know, trying to dig, you know. There's always like a high voltage battery. Let me get my pointer. And then you got capacitor bank, right? And then you got your electric motor and your fuel tank gasoline engine. That's the hybrid. Now, a hybrid's going to have more than one way of driving the car. That's what a hybrid is, basically. So if you had a mule that would pull a car or an electric motor that could pull it either one, that would technically be a hybrid. But when you hear ICE, that's internal combustion engine. There's a mechanical coupling, but this is oversimplification of what we're looking at. And so that's the first slide there. You might notice it's got a 12 volt battery. Even Teslas have got a 12 volt battery for the accessories and everything. Typically your high voltage battery is not grounded to the frame on the vehicle. It's a discrete circuit that's separate from everything else. And this is I got this from this Rosebro guy. He gave me permission to use this, and he created it. But basically, you got, as a part of this battery, you've got a computer, and this is basically for a Toyota Prius. And I had one of these batteries here. But you got a whole bunch of batteries stacked together in series. You know, even a 9 volt battery is a bunch of 1.5 volt batteries stacked together. To make 9 volts. You got 6 1.5 volt batteries and you got a 9 volt battery out of it. If you ever tear a 9 volt battery apart, you'll see that. You'll see 6 little batteries in there. And these inverters basically are going to take this DC current that's coming out of here and turn it into AC current to operate the motor. Now what you're seeing right here, this service plug takes the whole battery completely out of commission, you know, basically removes it. It breaks the circuit so that there's not any high voltage that's going to hurt you in any of the circuits. Of course, you got to wait till the capacitors discharge too, but they usually discharge pretty quick. And right here, you've got a little solenoid that closes and checks the integrity of everything, and then you got these contactors here that slap shut, and you might notice how they control everything. I mean, they basically, well, let's see. That's the one. That's the one that basically checks for a fault. And then 2 and 3 snap together, and 3 gives you your negative and 2 gives you your positive. See, but none of those go to the car. In other words, to the body of the car. And you got your high voltage ECU, and it can actually look at all the different batteries and try to, you know, you can pull it up on a scan tool and look at all the different battery cells and all that. These are bolted together. These are little flat 8 volt cells in this one here. If you take them out and try to charge them separately, they swell up. You can't get them back together. So you're not going to be able to do that. That little plug right there is that service plug. It's got to be pulled out. It's actually got a fuse on the inside of it. That's why he's got that drawn like that. And so anyway, I'll just give you a sort of a brief overview. And then they're slightly different from one to the other. This right here is the way a Ford Toyota is set up. Fords and Toyotas basically have got a planetary gear set, and you might notice that the engine is connected to the center. I see normal driving, you're using the engine there, and you can back up and look at this slide again if you want to. But whenever you're in reverse, you lock your reverse is always fully electric. I don't care if it's a Ford pickup or whatever it is. If you've got an internal combustion engine, it cannot run backwards. And these electric motors can run backwards or forwards. So they do whatever they need to based on the way this planetary gear set works. See, that little motor is hooked to the sun gear. The big motor is hooked to the ring gear, and the engine is hooked to the planet pinion carrier on this setup like this. And this was when I was at the hybrid school. We tore one of these apart, and there's your little motor, and there's your big motor. And it uses as I remember, it uses the big motor. Whenever you're hitting the brakes, it changes the electronics, so the big motor is generating, it's not slowing the vehicle down, because it takes, it resists the movement of that motor whenever you, kind of like an alternator. You might notice when an alternator starts putting out, it pulls the engine down. Well, whenever you, the way they use these, and believe it or not, these, I got sidetracked here, these are hand wound. They wind these by hand in some foreign country. That's what we were told. They may be doing it different now, but that's what they were doing in. But anyway, this one's the one that charges, that puts juice back in the battery. Of course, that's an inverter right there on top of that. Whenever you hit the brakes, it does regenerative braking, is what they call that. Now, this is a Honda setup. It's different. This little motor right here is sandwiched in between the engine and the transmission, and it's kind of an electric supercharger. Now, the earlier Hondas actually had manual transmissions, transaxles, but just all the Hondas now pretty much, all the hybrids now have got automatic transaxles, but the early Hondas had this one here. But that little electric motor, high voltage battery would drive that, and this is what it looked like in the back. Now on this one here, the way you would disable this one, so if you were going to work on the high voltage part, there's a little switch here that looks kind of like a breaker, and you flip that switch, and then you pull the cover off and turn it around so that it can't get flipped back on accidentally. And so that's just a little quick overview of the Honda. See, Honda's different from everybody else, and I kind of like the way Honda did stuff, because they actually put a 12-volt starter on their early one, so that even if the electric motor part of it went bad and the battery got to where it wouldn't work, you could still start that thing and drive it like you could in the other Honda, which was smart. That was a backup system, and sometimes Honda has some really good ideas about keeping stuff simple. But this is a tool right here that he was showing us to pull this this magnetic inside out here, and around here is all your windings that drive this coil. As the electronics walks the magnetism around, and this magnetized center part, the rotor, what do you want to call it, is actually driven by the magnetism that's chasing it around. But they use AC current to do it. We'll talk more about that a little bit later. Here's the fuel cell vehicle layout. You're going to have a fuel cell controller, and basically you've got a power management controller, DC to DC converter, motor controller. See, the fuel cell is basically creating electricity, and it's put into the battery pack, which in that particular case you can charge up the fuel cell with, if you're using hydrogen fuel or whatever. And the only exhaust that comes out of the thing is water vapor, basically. And of course, here's the funny thing about that. Water vapor is a more significant greenhouse gas than CO2 will ever be. That volcano that erupted over in another part of the world put enough water vapor in the air to where it'll warm the earth for about, 10 or 15 years, just because of the water vapor that one volcano blasted into the sky. It was an underwater volcano. And so that water's still up there, and it's taken a long time to come back down. That's another story. I kind of rant and rave about that. There's always an inverter between the battery and the AC motor, though. This is a sort of a, generic picture of a battery. A high voltage battery is going to go through the inverter, and then you're going to have the UV and W windings going out of the motor. Then you got mechanical transfer. This is a very basic schematic of that. Now, this is what that electronics looks like in an inverter, and it looks like, oh my word, what in the world are we going to do, But the long and the short of it is, you don't have to understand all of this. You don't have to understand this junk. Now you need to know where everything hooks up if you're going to work on one. And you shouldn't be working on one without gloves. You got to have the kind of training. Whenever Ford first came out with their hybrid Escape, they wanted the mechanics to put purple cones around and have somebody with a big long plastic hook, that if the guy started getting shocked by the high voltage, somebody could pull him off with a plastic hook, which was just crazy. Nobody else came up with that except Ford. But anyway, so now alternating current flows in two directions. This is going to be very basic for a lot of y'all. Higher voltage increases amplitude. This was I had a scope, an old CRT scope that I used at the college, and I created this, took this picture. Of course, you can notice it was sweeping across the screen, and I got wound up with getting, 3 little because of my shutter speed. Anyway, this is 0 volts, and it's going above and below 0 volts. Well, I put a rectifier in there that I got from Radio Shack, wired it up, and I showed them how when you put a rectifier in that circuit, which is a series of diodes that are hooked up to rectify AC current, it turned these bottom loops up, and it put them all on the top. Now, if you hook a capacitor in series with this, it will flatten that out, and you don't have those humps anymore. And so that was something else I used to demonstrate. But the AC juice is a constant polarity reversal. And you're basically, and it's hard to imagine in your mind how this would happen, but the electronics basically feeds that magnetism in there so that it spins this around. And that's, that's basically how that thing works. There are DC brushless motors. These are brushless, there's no brushes. But there's brushed DC motors and brushless DC motors. The electric power steering systems have got DC motors driving the power steering rack, but they're brushless. And any brushless motor you have, I don't care if it's a fan out of your computer, it's a little 12 volt fan that you can pull out of your computer. If you pull that fan apart, you're going to see a circuit in the center of that thing, behind that hub, that's making that brushless motor work. A brushless motor will not work without electronics. Some of your GM vehicles have got brushless DC fuel pumps now, and they've got to have a little module to drive that brushless fuel pump. Anyway, on the AC waveform, the higher the wave, the stronger the AC. If you've ever hooked a scope up to a wheel speed sensor, and you're turning the wheel really slow, you're going to see a waveform like this. A little bit faster, you're going to see a waveform like this. And the faster you turn it, the higher the voltage goes, the higher the frequency goes. This is amplitude here. Right here's what that is. So you're going to get stronger, more pronounced amplitude. That's why some of your wheel speed sensors now are digital, so that regardless of how fast or how slow you're moving, they can still tell the vehicle's moving, and they can even tell in which direction it's moving, believe it or not, in some of those sensors. Single phase versus 3-phase, you got 1 and 1B, 1 and 1A, and see on this one here, it walks that around to spin that motor. This is magnetic. The center of a brushless motor is magnetized, and the windings are what drives that magnetized center of the motor. Remember, in a permanent magnet starter, the magnets are on the outside, then you got a brushed armature in the middle. Now, 3-phase has got more hits per revolution and helps overcome the fact that AC is passing through 0 volts during its polarity cycles. So basically, you're always wanting some voltage pushing. You don't want it going jump. It makes it run smoother and stronger if you've got that. So basically, here you've got these things. See, now that one there is illustrating these transistors closed, but whenever it's driving that. Is making this one negative and that one positive, this one negative, that one positive, and then it goes around like that. And these transistors with all the electronics that are operating them are what makes that happen. And so that's not really too hard to understand. And once again, this is magnetized, and this magnetic field is what drives that motor. If you know anything at all about how a motor works, you can understand that. Now, the stronger we make the AC, the more work we can do. The faster we cycle the waveform, the less wasted time we have at 0 volts. That's what I was talking about earlier. All right. Now, alternators generate AC current. I recently replaced the alternator on my Explorer with one that I got from carparts.com because I didn't like the looks of this ripple. Anybody that's tested that knows that you got a ripple. Now, that ripple, this alternator was actually putting out, but I never liked that ripple. Ever since the first time I ever checked that alternator in my vehicle, it's got 93,000 miles on it right now or something like that. But it is, for years I've checked this ripple, and I've never liked it. And so finally from carparts.com I got a replacement alternator, and it made a nice, beautiful little even ripple all the way across after I got it swapped out. All right, the power inverter, you got high DC volts coming in, you got high AC volts going out to the motor. And that's This is a sort of a simple. This is from a Honda, the one that, and that's Craig holding it there. That's a picture I took when I was at the school. And inductance, bleh. Insulated coils have inductance. Inductance is a property that opposes changes in current flow. And so when you have coils in a circuit, the voltage will lead the current. That means you get voltage first and current follows. That means the voltage appears first if you're looking at it on a wave or a scope or something like that. Now, capacitance is the property that opposes changes in voltage too. When you have capacitors in a circuit, instead of the voltage leading the current will lead the voltage, and that's pretty important. Now, this is kind of what that looks like. See how you get your voltage here, and there's your current, 90 degrees right there. See? All right, and this right here is just a plain old resistance circuit, and this is the one with a capacitor in it, and the current leads the voltage. Now, the cool thing about capacitors, most everybody, well, let's talk about inductance for a minute. I'll go to capacitors in a minute. Put two coils of wire. This is the primary winding, this is the secondary winding. And when the magnetism that's created between the circuit is on these two, and saturates that, and then you break that circuit, and that's whenever this collapses and you wind up with a whole lot of voltage coming out here, and that fires your spark plugs. Now, in the olden days, the points did that, right? So mutual inductance between two coils is created in a transformer. I bought a transformer one time from Radio Shack. It was just a plain old transformer like you'd see in a portable radio or something. And I built a little board with that, and I used a rectifier, and I showed my students the difference between alternating and direct current. That's what I used to make those scope patterns I showed you earlier. And a capacitor is a non-conductor component that has got the ability to store an electrical charge. Now, any old mechanic that's been around will show you how you can lay this on the engine block and let the spark plug pop, 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 pop to that thing right there. Then you can lay this somewhere, and somebody's going to pick this thing up, and they're going to touch that and that, and it's going to knock the tar out of them. I'm not saying you should do this, but it was a trick that older mechanics played on younger mechanics for years. And it really doesn't hurt anybody, particularly if they're, because it's just a pop that, it's instantaneous. But unless it's a bad capacitor, if a bad capacitor will bleed off. But a good capacitor will hold that charge. It'll lay there for 2 or 3 days, and it'll still be charged up with that 30 or 40,000 volts. All right, so anyway, it's like a short cycle battery, though. If you want to do a little something to demonstrate, get you a capacitor. And you used to buy them at Radio Shack when there was a Radio Shack. Radio Shack went woke and disappeared. Anyway, the long and the short of it is you got this capacitor, and the capacitor's got a long lead and a short lead. And the long lead is going to be the positive lead, the short lead is going to be the negative lead, as I remember. So if you take an LED, and it's got a long lead and a short lead too. Okay, so you charge up that capacitor with just 12 volts from the battery, like that, so it's not dangerous. And then you touch the legs of that LED to that capacitor, that LED will flash one time as it discharges that capacitor. I could have probably demonstrated that, but I didn't have time to put that together. All right, so capacitors act like accumulators, in other words. They store DC voltage, and they can be deadly when they're discharged. If you get one like they use on an outside air conditioner unit or one of these out of a hybrid vehicle, you can take that thing and charge it up with house current, plug it into the wall, and then unplug it. And then if you get a big screwdriver and short across those two terminals, it sounds like a shotgun going off just about. It goes pow, and it's a rig. And if you do that with your hand, it's gonna cause you a lot of damage. So don't touch that with any part of your body, and you better have an insulated screwdriver whenever you do it the other way. But anyway, the capacitors in a hybrid slowly release their energy when the hybrid is shut off, but when you pull the connector, the service plug, you still need to wait for them to discharge, and you have to put on your gloves and get your Cat 3 meter and check to make sure that the voltage is not there anymore, because you don't want those things accidentally storing that up, and then you got high voltage that you didn't expect. Once you disconnect your service plug and you know there's no high voltage anywhere in the system, now when you take your gloves off and work on the thing like you would any other car. there was this guy one time that his wife called and asked if we could put an engine in a Toyota Prius. And I said, I don't want to know the backstory on it. And she said, well, my husband worked for the power company and he found a gasoline engine for this Prius, because the gasoline engine that was in it crapped out. And she said, they want $2,500 to change out the engine, just labor, because it's a hybrid. And so I said, have your husband give me a call. So he called me, and he was in his 60s, and I said, you work for the power company? I said, yeah. Are you familiar with high voltage? He says, yeah. And I says, well, you know where that service plug is? He goes, yep. I says, pull the service plug. That motor that you bought for $325 from eBay, I says, swap that thing out. Just pull it out, put it back in. You've done mechanic work before. He goes, yeah, I can change water pumps and stuff. And so I said, you can put that in there. You don't have to hire somebody to do it. You find the time. And so he called me back after the following weekend, and he said, I put that engine in myself, and it didn't take me about 5 or 6 hours to do it. Easiest job I ever did. I can't believe they wanted to charge me $2,500 to swap the motor out in that Prius. Now, I would have been really cautious if he wasn't somebody that had some mechanical skills, and if he hadn't worked for the power company. Because anybody and everybody can't do what he did. But the long and the short of it is, he was smart enough to where he knew how to put something back together the same way he took it apart. And he said that was he had nothing to lose, because he wasn't going to pay somebody $2,500 to change out that gasoline engine. And really the job wasn't that hard. All right, electrolytic capacitors are used in the high voltage DC side of hybrids, and they discharge really quick, just like capacitors always do, whenever their circuit's closed, to extend battery life by adding power under load to assist the high voltage battery. That's why they're there. If you've got a really heavy load and you need to get a good strong boost on your batteries, this bank of capacitors will discharge and help that thing out, and that gives it a little bit more zoom. And in an RLC circuit, and the reason is RLC is resistance, inductance, capacitance, all of those elements that we were talking about. Here is a series RLC circuit. See the capacitor in there, and here is a parallel. And see, there's the capacitors parallel with the load on that one there, and then there's a resistor in there too. But anyway, I won't spend a lot of time on that. You convert an AC to DC. You're going to use diodes to do that. You're going to anode, cathode. Everybody's seen a diode. The physical appearance of a basic solid state diode is there. Here's the symbol, and it won't let current go back that way, but it will let it go that way. What else needs to be said about a diode? It's a semiconductor. The alternator makes pulsed DC from three-phase AC. What's coming out of this stator is alternating current as that magnetized rotor spins on the inside of it. So this is basically the opposite. This is kind of like the big motor that does your regenerative braking. It becomes an alternator, so that you're driving that inside and you're creating current in the outside that's going back to the battery. So it kind of reverses everything, you see. And then you got these three windings here. And these three windings connect to the three parts of this. You got positive and negative diodes in here too. Anyway, that's a rectifier bridge. And so that is this, and this is that. And so that power comes out of there and goes to the battery as this current's being generated in there. But it has to go through this rectifier bridge. You notice one leg is hooked to a separate a separate diode pair. And one side of these are grounded, the other side, so it forces this current so that everything has to go in the same direction. And the only thing that can leave the alternator, is that positive current. The transistors are used like switches, like a relay with no moving parts. A lot of people have, transistors have got gate voltages too. I bought some transistors one time, just a pack of them, and I was trying to get them to work, and I said, well, I can't get these to work. And then I got to looking, and the gate voltage was 40 volts on those, and I said, well, no wonder, I'm using 12 volts here. But the base, whatever you put in the base, like for example an NPN, you're going to put positive in here, and it's going to make a connection inside there. Well, on this PNP, you put negative in there and positive flows through it. You see how that works? That's not really that complicated. And you know, we played around with those whenever I was teaching the students. Now there's other kinds of transistors. This is important. Metal oxide semiconductor field effect transistor, MOSFET, is a type of transistor used to control the flow of electrical current in electronic devices. Some of your HVAC systems will use these to drive the blower motor and that kind of thing. And they basically switch and amplify current and all that. An insulated gate bipolar transistor, IGBT, combines high efficiency switching of a MOSFET with a high current and low saturation voltage capability of bipolar transistor. And it's used in hybrid vehicle inverters. You notice it's even got a different symbol there. All right. Now let's look at this right quick. You got brushes here. It's magnetizing this, and you got permanent magnets out here. Now in here, the permanent magnets are on the inside, and you're sending this current into these windings to drive it. See that? So the motor is driven by magnetism in both cases, but the magnetism, the permanent magnets are on the outside on a brushed motor, and the permanent magnets are on the inside on the brushless motor. But once again, you got to have electronic circuits that can walk this around. Now your hybrid motors, a lot of them have a resolver, which is a kind of a feedback, so that the controller, the way I understand it, so the controller will be able to better operate the motor more smoothly and more powerfully and everything, because it's sort of like it needs to know exactly where the motor is, so it'll know when to send the pulses to the coils and all that kind of stuff. Alright, so three-phase DC motor control. There's your these integrated bipolar transistors. Anyway, there's your battery, and it's got one little 1.5 volt battery showing there. But you got your U, N, V, and W windings. You might notice that these hybrid motors will have 3 big cables connected to them, and those big heavy orange cables too. I mean, and this is just the windings. This kind of looks like an alternator, but it's not. It works vaguely the same way, but you can see how if they did that the right way, whenever this is being driven, it would create current in here that would go back into the battery. See? All right. Now this right here is a brushless motor, and see, whenever you've got that U, V, and W, see how all of those are keeping that thing away from 0 all the time. You know, there's some controversy. Some of the mechanics that do this kind of stuff overseas say that this is not an accurate. I didn't draw this; came from somebody else, but they said this is not accurate. That's not the way that works. Blah 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 blah. Whatever. But it doesn't really matter, because if somebody can build something that will work, you don't have to understand every last little aspect of it to fix it. Matter of fact, on these Priuses, the way that you can tell, if the way we were taught when I went to one hybrid class up in Kansas City, you can tell if the transaxle, with the windings in it, you can tell if the transaxle is bad by just pushing the vehicle when it's in neutral. And if it doesn't roll smoothly, if it gets hard and easy, you got a bad transaxle. It's just not that complicated, you know. Now, AC can actually power brushless electric motors with a great force. And so AC can overcome resistance better than DC, and AC can be controlled easier in an electric motor application. Furthermore, though, your brushless power steering DC motors, and there's some little electric water pumps on some of these hybrid vehicles, and they're basically brushless, but they're also DC. See, there's brushless DC and brushless AC. The brushless DC motors in your electric power steering, they opt for that because what they want is they want you to have plenty of strength. They don't want it to have to spin up to have all its strength, you know, because a DC motor will typically have to get spinning pretty good, you know, before it gets it reaches the peak of its power. An AC driven motor doesn't do that. DC to DC converters, you got this, I just put 140 volts there. It can be a lot more than that on a lot of these hybrids. That comes in, goes through this transformer, coming out we got 14.5 volts. You can actually energize your system with your Cat 3 meter, hook it to the 12 volt battery, and energize the system and see if you get 14.5 volts there. That'll tell you that part of it's working, see, because it charges the 12-volt battery, and the 12-volt battery is what operates your accessories and that kind of thing. So, and all of these systems, hybrid EVs, they've all got a 12-volt battery. Well, that's going to be the end of it. This is a picture I took in the back of a 2010 Ford Fusion. There's the disconnect plug and so on. These are the controllers and all that kind of thing. And I hope you got something out of this and enjoyed it. And we're coming up on a nice even 30 minutes. And I appreciate you guys watching. Share the video. See you next time.